Hi everyone, it's Mrs. Torigno again, and I am back with page 6 of the second packet of the Algebra 1B Semester 1 exam review. This video will just cover questions 35 through 37, but all of these questions are kind of intense because they involve graphing and then reading your graph. So that's why we're only covering 3 questions here on this page. And I've taken the equations that are given to you here and just rewritten them so that hopefully you can see them as I'm pointing to them on the screen. I know that this is coming out just a little bit blurry, so I thought this might help. Okay, this wants you to graph a system of equations. And remember, a system of equations is 2 linear equations at the same time, which means that this graph should end up being 2 lines on the graph. So we need to graph 2 linear equations. Now these are both written in different formats. Notice that this one has y all by itself. That's what we call slope-intercept form. This one has x and y together on one side and the number on the other. That's what's called standard form. I would actually graph these 2 different ways. Now, you absolutely could use either method for either equation, but I'm just trying to point out what I think would be the easiest way to go with both of them. With this first one, I would use the fact that it's in slope-intercept form and start my graph at the y-intercept. Remember, that's y equals mx plus b. And the b always gives you your y-intercept. So that tells you where to start your graph. I'm going to go to 1 on the y-axis and put a point. And then I want to look at the slope. The slope is this number that's in front of x, and you can always turn it into a fraction because we like for our slopes to be fractions. You can always turn it into a fraction by putting it over 1. So that slope is -2 over 1. Remember that slope is rise over run. So the top number tells me how far to go up and down, and the bottom number tells me how far to go left and right. And pay attention to the signs to determine which direction you're going. For example, this is -2, and that's my rise. So if I rise -2, that's really like coming down 2. Okay? And then my run is +1, which means I'm going to move 1 to the right. And I've showed you in class that I would actually do this a couple of times. I would go down 2 and over 1 again. Oops, am I seeing this okay? Got a little bit of a glare. Down 2 and over 1. Especially these ones that are asking you for a solution, because you really have to make sure your graphs are drawn accurately so that they cross at the right spot. If you just sort of sketch it, you might get the wrong answer. Okay, and I am actually going to use a straight edge here. I can't locate a ruler off the top of my head, but this will work. Okay, so I'm just using this as a straight edge, so I make sure to draw my line nice and straight. And on the day of the exam, if you would like a ruler to use, you certainly could. Okay, and I would also suggest that you extend your graph as far across, or extend your line as far across the graph as you can, so that you don't miss the intersection point. Okay, so that does it for that top equation. We already took care of that top one. Now I need to look at this bottom one. X minus 2y is equal to -7. Because that's in standard form, I would probably graph that using the intercepts. That's just what I find to be the easiest way to go with standard form. If I'm looking for the x-intercept, remember that means y equals 0. So I'm going to cover up my y term, and I end up with x equals -7. Okay, that means I'm going to go on my x-axis, and forgive me while I count here, and go to -7. Okay, then I'm going to go to my y, and to find my y-intercept, I want to cover up the x, because x would be equal to 0. I would end up with -2y is equal to -7. So this one's going to take a little bit of solving. Divide both sides by -2, and you end up with y is equal to 3.5. Which means I'm going to go along the y-axis, go halfway between 3 and 4, which would be about there. Okay. Now in this case, there's not really a way to do more points, so you've really got to make sure that you're accurate when you calculate those intercepts. And then I would draw my line. Okay. So there's my 2 linear equations. Now, like I said, I use 2 totally different methods to graph those equations. I could have in this slope-intercept form, I could have calculated the intercepts the same way. I just find that a lot of the times that gets to be a little bit more confusing, but if you're okay with that method, go ahead and use it. Similarly, I could take this equation and rearrange it to slope-intercept form and graph it using the same method I did up here. So that's where you would solve for y. You would get y by itself, and that would work as well too. So whatever you're most comfortable with is totally fine with me. Bottom line, the solution to the system is this point here where they cross. And that looks to me like it's at -1, +3. So I would say the coordinate where they cross is -1, +3. Now I have seen some of you figure this out mathematically first, where you use substitution or elimination and then come to this conclusion. That is okay. I think that's a great way to check what you're doing. But remember, if the question asks you to graph the system, you do have to draw the graphs. But this is a really good way to know if your answer came out correctly. You could also just take your answer after you've graphed it and plug this in for x and this in for y into both equations and make sure that they work out correctly. Okay? And that would tell you whether or not your answer was right as well. So there's a lot of ways to check your answer for these problems. So make sure that you don't just hurry through it and then move along. Okay? Okay, let's look at that next one. That next one gives me -3x plus 4y equals 12, and then it gives me just x equals 4. Well, that top one, again, is in standard form. So I'm going to do the intercepts trick with that one again. I'll do that down here. Okay? If I am looking for the x-intercept, I always know that y is 0. So if I cover up that y, I end up with -3x equals 12. When I divide both sides by -3, I end up with x equals -4. Okay? So I'm going to go to -4 on my x-axis, 4, and put a point there. Now let's do the y-intercept in that same equation. For the y-intercept, I'll cover up the x. So I end up with 4y equals 12. Divide both sides by 4. And I end up with y equals 3. So then I'll go to the y-axis and put a point on the 3. And draw myself a nice straight line. Okay. My next equation is sort of a quirky one. It's x equals 4. I would really hope by this time you can look at that equation and tell me what kind of line it's supposed to be. But let's say that you didn't know what type of line that was supposed to be. You can't really use slope-intercept form because there's no way to write that in slope-intercept form, and the intercepts are kind of confusing too. So if you absolutely have to, this is what you could do. Make yourself a T-chart. Okay, x, y. And this is telling you that x has to equal 4 no matter what. So I'm going to fill in some 4s. X has to be 4. Y can be anything I feel like, okay? Because this only tells you what x has to be. It doesn't tell you anything about y. So maybe y is equal to 0, or maybe y is equal to 2, or maybe y is equal to -3. I'm totally making those numbers up because this equation doesn't give me any criteria for y. It only tells me what x has to be. Once you have those coordinates, you can graph them. So 4, 0, 4, 2, and 4, -3. And as you can see now, this is going to come out to be a vertical line. Like I said, probably most of you can look at that equation and say, all right, I know that's going to be a vertical line. But just in case you didn't, I wanted you to have that survival strategy. Okay? Now I'm going to look for the coordinates of my intersection point, which look like right there. And I know that my intersection point better start with a 4 because this equation says x equals 4. There's nothing on this line that doesn't start with a 4. So it has to be 4, something. And I guess all I'm really left to find is what the y coordinate is. So that'd be 1, 2, 3, 4, 5, 6, I believe. My star kind of covers that up, but oh, let's see. Let's say I'm not sure about 4 comma 6. Okay, maybe I counted wrong. I can plug it back into this top equation. I know it works in the bottom equation because my first number is 4, and that's all this bottom equation says. X has to be 4. Let's plug it into the top equation to make sure it works. I'm going to find some space up here. I know I'm kind of jumping around, but so that top equation was negative 3x plus 4y equals 12. So if I want to check to see that this works, I want to plug in 4 for x, negative 3 times 4, plus 4 times 6, and I want to know, does that really equal 12? Well, this is negative 12. 4 times 6 is 24. Is it true that negative 12 plus 24 is equal to 12? Yes, it sure is. Okay, so that's how you would go about checking your work for one of these problems. Now, technically, we should plug that coordinate into both equations to make sure that it works. And that's something you don't even have to write out. You could just check that right on your calculator. But with this equation, like I said, because of that weird one, because of the x equals 4, I already knew that this equation would work in that because all I need is for x to equal 4. Okay? Okay, onward to number 37. This one is a linear inequality. And remember, inequality just means it has a greater than or a less than in it. So that means I don't want just a line, but I need a shaded half of the plane to show me where the values are less, where the y values are less than or equal to 1/2 x minus 1. This is in that slope-intercept form again. So I'm going to use that. I'm going to start at negative 1 on the y-axis. And my slope is 1 over 2. Remember, rise over run means then that I would go up 1 and to the right 2. Okay, again, let's do that maybe a couple of times. I have a hard time seeing over my light here. Okay, up 1 over 2 again would put me right there. Okay, before I draw my line, I need to think about what type of line I should be drawing. Since this has an equal to bar, that means I want to include the line in my answer. So I'm going to use a solid line, and that will be true anytime you have an equal to bar underneath your inequality. Whether it's greater than or less than, this little equal bar is what I'm looking at, okay, to decide that. And then it's really important that you know, just by looking at that, that is a less than symbol. And again, if you're confused by that, imagine I just picked this top little line up. Do you see that if I unfolded it, it would make a letter L? L for less than. Okay, if it doesn't make a letter L, it must be a greater than. Less than means I'm going to shade underneath the line. And with linear inequalities, you are always talking about above the line and below the line. So less than would be below, meaning I want to shade down here. Okay? If this had not had this equal bar here, I would have used a dotted line instead of a solid line. And if this had been a greater than instead of a less than, I would have shaded the top half of the plane. So those are some of the decisions you'll have to make when you're graphing one of these. Okay, that's it for this chunk of material. I'll pick up with problem number 38 in the next video.